have you ever had your parents line you up on the wall and they put a little line above your head?
Yes. No.
And then when you get a little older, they do it again. Every birthday, they kind of measure you.
Yes.
They want to see how much you're going to do what? Grow. Okay? Now, I want you to look here. I have circles on the board. 1 circle, 2 circles, 3 circles. What do we think is going to go next?
4 circles.
4 circles. It's pretty obvious, right?
5 circles and 6 circles.
Well, you seem to know what you're doing, Natalie. Can you go and finish the pattern for me? Okay. What kind of pattern do you think this is? What kind of pattern do you think this is?
Triangle pattern.
A triangle pattern. Tell me, why would you say a triangle pattern?
Because, like, how the way you put the circles, it forms a triangle.
Okay. That's not quite what I'm looking for, but I like your creativity. I like your thinking. But what type of pattern is this? Yes.
I was going to say a stem and leaf plot.
A stem and leaf plot. That's something else we learned. You're using some mathlish, but that's not what we're looking for. But good answer. Yes.
A ones pattern.
A ones pattern. And why would we call it a ones pattern?
Because you add 1 to each number.
Great. That's a good observation. She says we're adding 1 to each one, but that's not the type of pattern it is. Remember we talked about a little child, and as they were
Growing. It's a growing.
a growing what?
Pattern.
Okay, it's a growing pattern. And why is it a growing pattern? I can't hear you unless I see your hand. I see your hand, Jules.
It increases by 1.
It increases by 1. So each number, it grows by 1. That's why they call it a growing pattern. Okay? Now, does everyone understand that?
Yes.
Yes. So if I were going to continue this to 20, how many circles would there be?
20.
It would be 20 circles, right? Because each step continues to grow. All right? Any questions on why I called this a growing pattern? No? Okay. Last class, we learned a very important math term.
Conjecture.
Conjecture.
All right, I got it.
You got it. 1 clap for Natalie. Good job. All right. Natalie, you said it. What is a conjecture?
A conjecture is like a hypothesis, but in math.
Okay, but what is that? If I had no idea what a hypothesis was,
It's like an educated guess.
it's like an educated guess?
It is an educated guess.
All right, but we're just using it in math, right?
Yes.
Okay. What I want you to look at, these are windows. This is 1 window, 2 windows, 3 windows, right? You see my windows? They may not look like the ones at your house. I don't have blinds and curtains, but these are my windows. And in order to make this window, I needed 4 sticks. We're going to consider each side a stick, okay? 1, 2, 3, 4. We understand that?
Yeah.
Yes. All right. So for this 1 window, how many sticks did I need?
1.
I only needed 1 stick to make this?
4.
Okay. How many people say I need 1? 1 stick to make this. Okay. Where's the 1 stick? Oh, talk to me. Why did you say 1?
I thought you meant by each side.
Each side. This is a stick. This is a stick. This is a stick. And this is a stick. So how many sticks do I need for 1 window?
4.
4 sticks. Okay. I need 4. All right. Now, for 2 windows, how many sticks do I need?
Either 6 or 7. I'm not really sure which one of them.
Okay, either 6 or 7. Think through it. I'm not going to let you get off that easy. You know I don't do that.
What I meant was...
Go.
Like,
Come on.
Like, I'm not sure, like, counting... Well, wait. Wait. Never mind. 5. Because this is 1 long stick, 3 short sticks, so 5.
Okay, he's not agreeing. Oh, I see a lot of answers, question marks on top of everyone's head. I see the question marks. Yes.
7 sticks.
Okay. Come show me and explain why.
You need 7 sticks because this is not a round stick. This is just like this one, but in 2. So you put 1 stick here, 1 stick here, 1 stick here, 1 stick here, 1 stick here.
Okay. Use your blue marker. Get your blue marker and show me just like I showed you here. This was 1. Show me where you have 7. Okay. Do we agree or disagree?
Agree.
We agree. All right. So for step 1, I'm just going to put step 1. We had 4. All right. So for step 2, how many?
7.
7 sticks. All right. Step 2, there were 7 sticks. All right. I need a volunteer to help me with step 3. Step 3. Kristen, you've been kind of quiet. Come on up. Step 3, Kristen. Okay, and what is your answer? Don't run away. Go back. Okay, tell us what your answer is.
The answer is
Count it for me. Count it out loud.
1, 2, 3, 4, 5, 6, 7, 8, 9,
10. Do we agree?
10. Yes.
All right, so for step 3, how many sticks?
10.
You don't seem sure to me.
10.
Oh, okay, so we do agree that there are 10.
Oh. It's like this, and then you start out with 4, and then you have 3 more, and then 7, and then 10. Thank you.
Exactly what we're doing. And what is that? What is that?
Kind of a pattern, you have to find it sometimes.
We find the in and out. Keep talking to me, but there's a term that we call these. There's a term that we call it. Who remembers? If you remember input and output, you should remember, yes. Come on. Out and in and out. Yes. Increase and decrease. Oh, God, you're using some great words. But what is this table just called that he just made? Starts with?
Andre, please come to the main office. Andre, please come to the main office.
Starts with an F.
No.
I think I heard someone getting ready to say it. Next letter is a vowel.
What's the next letter?
You want me to just spell it out? You want me to just give it to you?
No.
Well, think. Come on. Put those thinking caps. I heard it. Table 1. Thank you. When looking at this activity, the first thing that we started out was talking about the sticks with the windows. I worked through it with them, with the sticks and the windows. So they appeared to get it, and they thought, oh, we got this. This is pretty easy. However, we moved to the dots, which was the second one, which was more independent. They had to work as a team. And I noticed that they did not understand how to get to the pattern or how to get to the rule. They didn't have the windows anymore. That was taken away from them. So now it's something totally foreign to them. And it was a little more complicated, I must admit. But the students did not have that knowledge of how to do it. They struggled through it. They struggled with the dots and trying to figure out how can I get the pattern, and they looked for the same pattern that applied to the windows. And they realized that rule is not going to work. They had no idea there was a whole nother rule and there was a whole nother pattern to try to figure out. So I think with that, the students had to come back and say, okay, how are we going to do this? And they realized one student, Natalie, was like, I just don't know where to go from here. I'm just tired. I don't know what to do. And so at that point, it took Jules from another table to say, I know what I'm doing. And Jules was able to go over and say, you know, this is how you do it and to work through it. And then the light bulb came on. So it's not that Natalie got so frustrated that she didn't want to do it anymore, but she needed that extra push and she needed that extra guidance. And so once Jules came over, then the light bulb came on and it was like, oh, so this is how we do it. And she was able to continue and proceed with the process from there. Being that today's lesson was an introductory lesson for them, they had never seen functions before. It was a very difficult process because the students can look at a pattern. They can physically look at a pattern and tell you the algorithm. I added 2, I added 3, I added 4. But to try to get this into an equation was difficult because the students had to take something that was very concrete to them. They can actually count the number of dots they saw and make it into something that was more abstract for them. I think bridging that gap between the concrete and the abstract is difficult at this stage for something that they've never seen before, something that was very new to them. So I feel that was the struggle there. And it was frustrating, even as a teacher. I was like, oh, I really want them to get this. And being that you only have an hour in a math block, I'm like, oh, I need 30 more minutes for them to really get it. So we had to close the activity. That's why I say I know I have to go back into this, you know, next lesson, because I don't feel the bridge was totally built yet. Will everyone's rule be the same? No. Because sometimes you may find one way to do it, and Table 1 found another way to do it. What are some ways that we can find patterns? Somebody drew a diagram. What else?
You can sort of like see the difference between them.
By looking at the... All right, but what are we looking at? What were the little things called?
Dot.
The dots or the windows, right? We can look at the picture. And what else can we do?
We can just try to find the rule and then you figure it out by there.
Okay, but what if we can't figure out a rule? And what do I do to figure out the rule? What can I do to figure out the rule? To figure out the patterns. Okay. I believe we take as long as it takes for the students to get the lesson. I don't have to get it all in one day. I'm not trying to build something within our students that's 10 miles wide and 1 mile deep. I'm trying to go 10 miles deep and only 1 mile wide. I want the concept to be inbred in them. I want it to be deep inside. So I need to take as long as I need to take. So just because you do not get through in one lesson does not mean we cannot continue the next class. The students need to understand the concepts. It needs to be deeper. We need to teach with more rigor. We need to make sure that the concepts are taught to the fullest extent. Do not just teach on the surface, because that's what a lot of us as educators, we do. We'll teach on the surface to say that we've taught it. I've taught chapter 1, I've taught this benchmark, and I'm finished with it. But do the students really understand the concept?